For our last section before spring break, we're going to talk about the areas of circles, sectors, and segments. Right now, those last two words should not mean a whole lot to you, and they are special segments or special portions of circles, and we're going to look at where those are. So today, it's all about relating what we know about area to portions of circles. So first, as we start off, the basic thing that we need to remember is the area of a circle. So hopefully you remember this. If you do, go ahead and write it down. The area of a circle is equal to pi r squared. We used this a lot last unit. We're going to use this again today and in this section. So that's our first foundation that we need. The area is equal to pi r squared. Next up, we are going to talk about a sector of a circle. So a sector of a circle, if we have our circle and our circle has a center, the sector is the pie slice that's formed if I draw two radii from the center and choose to shade the region. You could either take the smaller region or the larger region. In this case, let's say I take the smaller region. This is the sector of the circle, this region here. And if we want to find the area of it, it's the area of the currently shaded region. So when it comes to this area, hopefully you'll remember from the last section that what really matters is what fractional percent of the whole circle is the piece that we have, and we use that with a relation to our central angle, which we have been calling theta. So we actually saw a formula for this last unit, but I'm going to give you a slightly rearranged version that I like of this formula, and then I'll also give you the old one. So if I want to know the area of a sector, I think one of the best ways to find it is using this ratio. So we're going to set up two proportions and set them equal. The ratio is this: the area of a sector over the area of the circle, the total area, is equal to theta, which is our central angle, divided by 360. So the area of the sector to the area of the circle is equal to our central angle theta over 360. Or you might have also seen this written as the area of the sector is equal to theta over 360 times pi r squared. This really is the formula if I cross multiplied it, or if I multiplied by the area of the circle, move that to the other side, and then replaced area of the circle with pi r squared. So it's just a rearranged version. They mean the same thing. You could use either version depending on what you like. All right, so next up, for a segment, so that we can build off of this picture, I'm actually going to copy the previous image. And then I would just like to get rid of my current shading. Here's what a segment of a circle is. If I take the two intersection points with the radii that I've drawn in the circle, and if I connect them with a line, I form like a pizza crust kind of wedge here. And if I were to shade this piece in, if I connect here, it's the leftover piece between the circle and the triangle that's formed with the radii and the line connected. And so this shaded piece here is a segment of a circle. So the whole wedge is called a sector. If I cut it off with a line segment, it is called a segment of the circle. So it's the region bounded by a chord of a circle and its corresponding arc. And then we can connect the two radii if we want to here. So that's a segment. And for the area of the segment, if we connect these radii here, we can see that the area of our segment would be equal to the whole sector, the area of the sector, minus the area of the triangle that is formed. So there's not one nice complete formula that I can give you, but if we can find the area of the whole wedge, the whole sector, and then subtract the triangle, that will leave us with the area of the segment. All right, those are our big formulas. Let's look at a couple of examples. In this next part, they ask us to find the area of the sector with radius of 12 and a 45-degree arc. So if you wanted to visualize this, we have a circle, and remember 45 is half of 90. So I'm going to draw about like half of a right angle. And the radius is 12. And then this angle at the center is 45 degrees. So the shaded region is the area we would like to find. So if we want to set up and use our proportion, the area that we're looking for of our sector over the area of the circle is equal to our central angle over 360. So if we plug in our pieces here, the area of our sector, and then over the area of the circle, pi r squared, well, that would be 144 pi is equal to our central angle, which is 45, divided by 360. So if jumping to 144 confused you, the area of this circle is pi r squared, so it's pi times 12 squared, so it's 144 pi. So I did that work in my head and then plugged it in. So you have a couple of options here. To keep it as exact as possible, I would go ahead and reduce this fraction first. So when we reduce it, 360 is actually divisible by 45, and it leaves us with, when you divide 360 by 45, it leaves us with 8. And so this would mean our area over 144 pi equals 1 over 8. So then lastly, if I want to solve for a, you could cross multiply, or you could just multiply at this point by 144 pi. So that means that our area is equal to 144 pi divided by 8. And then when we do 144 divided by 8, which is a great question, I don't have my calculator up, 144 divided by 8, that gives us 18 pi. So that gives us a total area of 18 pi for that segment there. So if you think out of 144, the sector that we have is 18 pi units squared with its area. So that's an example of a sector. Let's look at an example of a segment. Alrighty, so here they give us a couple of pieces of information. They tell us that OA is congruent to AB. They tell us that AB is 6 units long, and they ask us to find the area of the segment. It's real important that you pay attention to sector versus segment, because that's really going to change your process here. When it says the area of the segment, that's going to be the section between the chord and the circle. So what now I have shown in red here. So for this one, we need to know two pieces. I need to know the area of my sector. I also need to know the area of my triangle. Now, depending on what you're finding, sometimes the ratio that we used above, it can work nicely for those who have a hard time remembering all the pieces. Sometimes it's easier to remember a proportion. I actually personally learned it with the second formula, and so I trend towards using this. For the sake of showing you both, I'm going to do this example with the second version. They are the same thing, just a rearranged form. So using the second formula, it would be theta over 360 times pi r squared. So just so you know where we're heading. Here's the thing, I don't yet know what my central angle is. So I want you to stop for a second. I want you to ask yourself, what is it that we know about this triangle? So hopefully you can think, all right, well, I know that both radii are congruent. So based on my markings, all three sides are congruent. That means this is an equilateral triangle. That means my central angle is 60 degrees. So that means when we go to our formula, theta is 60 over 360 times pi r squared. Well, if it's equilateral, that means the radius is 6. So that's times pi times 6 squared. So what I usually do is, let's see, I know that I can cancel out a 0. And I know that 6 goes into 36 6 times. So that leaves me with 1/6 times, and then this becomes 36 pi. Lastly, 6 divides into 36 6 times again. So that gives us an area of our sector of 6 pi. And then now I need to find the area of my triangle. And since it's equilateral, you could do 1/2 base times height. You could find the height, but we use our equilateral triangle formula, which, as a reminder, is s squared root 3 over 4. So that gives us 6 squared, which is 36, root 3 divided by 4. 36 divided by 4 is 9, so that gives us an area of 9 root 3. So now in total, the area of my segment is equal to the big section, which would be the sector, so that's 6 pi, minus the area of my triangle, which is 9 root 3. And if I asked you to give me an exact answer, this is the exact answer. I know it's not pretty. I know it's not what we're used to, but this is exact. But let's say I'm curious how much that actually is. We can go to our calculator, 6 pi minus 9 square root 3, and that is 3.26 units. So that gives us a better idea of what's going on here. All right, let's go through the next one here. Alrighty, so for part C, I have given you a circle O with radius of 4. So I know that my radii here are 4. And then they told us that OA was perpendicular to OB. So I know that I have a right angle here. And then it asked me to find the area of the segment, which they have already shaded for us here. So we have to think about the different pieces that we know. So in this case, for my sector, the central angle that we have is 90 over 360. So I do need to find the area of my sector, and I do need to find the area of this triangle. So let's start working through those pieces. If you want to pause and try to do this on your own, this would be a great formative check to pause it, try to work through, can I figure out how to find the area of this sector? Can I figure out how to find the area of this triangle? Now I'm going to keep going. So for our central angle, since it's right, that means it's 90. 90 over 360 times pi r squared, our area of our circle. And I'm going to jump to the fact that that is 16 pi. Now, if you look at it visually, you can start reducing these numbers. That's great. 90 is what fractional part of 360? It's a fourth of the whole circle. So we're going to take 1/4 of our area of 16 pi. 1/4 of 16 is 4. So this sector has an area of 4 pi. Moving on to my triangle. For most triangles, this is not equilateral, so we have to use 1/2 base times height. Since this is a right triangle, I already have a base and I have a height of 4 and 4. So this is half of 4 times 4, which is half of 16, which is 8. So now putting those pieces together, that means for us here that the area of my segment is the sector, which is 4 pi, minus the area of the triangle, which is 8. And that is our answer. Alrighty. This last example is another place where you can have extra practice. As you work this through, I would encourage you to pause here. I would encourage you to work this through and find these areas. What I'm going to do here in just a second is I'm actually going to give you the answers here in this video. So if you don't want to hear the answers right now, I will go ahead and pause it, work it through, and this piece you will be doing a little bit more thinking, less about sectors and maybe more about intersections of other shapes and circles. And then part C is a nice challenge level question. So if I'm about to write the answers on here, so if you want, go ahead and pause it. And then here we go. For number 3, part A, when you work through the exact answer, it comes out that the area of the shaded region is 256 minus 64 pi. And then for part B, the area of this shaded region is 64 minus 16 pi. And if you're curious for where that work comes from, the key has more work. You can look at that from there, or you're welcome to ask me questions. All right, that is the end of our last section for this week. I will be communicating more with you, but I do hope that you enjoy this last section and before spring break, and that you have a nice restful spring break.